Hey, Algebra 2. We are starting a different way to solve a quadratic equation. We've been factoring and understanding how that works, but sometimes it doesn't work. That doesn't mean necessarily that there's no solution. It's just might not be a rational solution. For example, let's remember the how the graph of the parabola lines up with the solutions of the equation of a quadratic. Okay, here's 2x squared plus 4x equals 0. We've been factoring this. We quizzed on it. I think this was the very first thing we did, was taking out a greatest common factor. Okay, so for example, I notice there's two terms. Okay, so it's not that trinomial backwards FOIL type. There's a plus sign. It's not the difference of two squares. I'm looking for something that they have in common, which is a 2x. When I take 2x out of each of these, and sometimes I put 2x under to remind me that I'm dividing, 2x squared divided by 2x, there will just be an x left over. You subtract the exponents. 2x into 4x, 4 divided by 2 is 2, the x's cancel. I can always do a quick distribution in my head, making sure that if I take 2x and multiply it back through, I do get 2x squared plus 4x, and I do. So from there, when I have a product equal to 0, I know one of the factors has to equal 0, so either 2x equals 0 or x plus 2 equals 0. One of those two or both have to be true. For 2 times x to equal 0, x would actually have to be 0. For x plus 2 to equal 0, x would have to be negative 2. Those would be the solutions to this quadratic equation. Graphically, if I graph y equals this part, y equals 2x squared plus 4x. Okay, oops, I kind of squared in, didn't do that very neatly, did I? Y equals 2x squared plus 4x. If I graph that, where does that equal 0? Well, at negative 2 and 0. Graphically, when I factor, I'm finding the x-intercepts. Okay? So the solutions to a quadratic equation are the x-intercepts when I graph it. Okay? They're also sometimes called the roots. They're solutions, x-intercepts, the roots. You'll hear them called the zeros. These are all terms for solving a quadratic equation set equal to 0. All right, and graphically, they're the x-intercepts. Okay, y equals x squared minus 9. This is one of our favorite types, right? Difference of two perfect squares. If I was going to factor it, let's go over here. If I was going to factor it, I would immediately know that was x plus 3, x minus 3. Difference of two squares. Okay, square root of each, once with the plus, once with the minus, then that middle term cancels, etc. Again, I have a product. In order for this product to equal 0, either x plus 3 has to equal 0, or x minus 3 has to equal 0, or both. For x plus 3 to equal 0, x would be negative 3. For x minus 3 to equal 0, add 3 to both sides, so x would have to be 3. Well, look what happens when I graph y equals x squared minus 9. The x-intercepts are negative 3 and 3. Okay, the x-intercepts are the solutions to the quadratic equation set equal to 0. And then we, of course, have the type where we have a trinomial. Now I don't have anything in common to take out. It's not the difference of two perfect squares. These were the ones where I have to play a little bit, trial and error, guess and check. I'm thinking, well, the only things that multiply to x squared are x and x. What multiplies to 10 might be 10 times 1, but there's no way that 10 plus 1 or 10 minus 1 equals 3. The other thing that multiplies to 10 is 5 times 2. And then I notice that if 5 is negative and 2 is positive, when I FOIL this back together, I get x squared plus 2x minus 5x, that'll give me the minus 3x in the middle, minus 10. So I have it factored. These two multiply to equal 0. So either x minus 5 equals 0 or x plus 2 equals 0. If I add 5 to both sides, I get x equals 5. If I subtract 2 from both sides, I get x equals negative 2. The solutions to this quadratic equation are 5 and negative 2. And look what happens if I graph y equals x squared minus 3x minus 10. The x-intercepts are negative 2 and 5. The x-intercepts are the solution to the quadratic equation. Sometimes they're called the zeros, sometimes they're called the roots. Okay, then this last type, when we have a 3 in front of the x squared or a 2 or something other than a 1, it gets a little trickier, but we're still just doing the backwards FOIL. I think to myself, what multiplies to 3x squared? Well, the only thing I have are 3x and x. Okay? What multiplies to 32? Oh, I don't know, 16 times 2? Then let's look at our outer product and our inner product. Is there any way that our outer product, which is 6x, and our inner product, which is 16x, would combine to give me my 4 in the middle? Nope. I picked the wrong things that multiply to 32. Maybe it's 8 times 4. That's 32. Well, then now my outer product, 3x times 8x, that's 24x. And this is 4x. Yeah, no, that's not going to give me 4. Let me try 8 and 4 the other way. I should have tried 16 and 2 the other way. I'm hurrying a little bit. Sorry about that. 8 and 4 this way. Now my outer product is 12x. My inner product is 8x, and 12x minus 8x will give me the 4x in the middle. I would like the 12x to be positive and the 8x to be negative, since I notice my 4 is positive. So in order for 12x to be positive, the 4 will have to be positive and the 8 will be negative. Great. I found it. I can do a quick FOIL just to make sure, but I already did my outer and inner, so I'm pretty sure this works. This is a product. Either 3x minus 8 equals 0 or x plus 4 equals 0. So to find this answer, I will add 8 and divide by 3. 8 thirds, what's that? 3 goes into 8 twice with 2 left over. So 2 and 2 thirds or negative 4. Those are my two answers. When I graph y equals 3x squared plus 4x minus 32, it crosses the x-axis at 2.66666. That's 2 and 2 thirds and negative 4. Okay? So, let's move forward here. Here's x squared minus 6. That's not the difference of two squares. 6 isn't a perfect square, right? It's not 3 terms. I can't take something out. I cannot factor this, guys. This is not factorable. Last week, that's what we would have written, not factorable. This week, we're learning a new method. It does not mean that there are no solutions. Look what happens when I graph y equals x squared minus 6. It crosses at like about 2.5, it looks like. I mean, this is rounded off. 2.5 and negative 2.5. Those are just decimal approximations, okay? So these x-intercepts are actually irrational numbers. If they're irrational, if the x-intercepts are irrational, that the answers are irrational, we can't factor that, okay? We can't find things that multiply to 6. Like, there's no perfect, 6 isn't a perfect square. It doesn't mean we can't solve it. We do something called the square root method. I just get whatever is squared equal to something else, and then I take the square root of both sides. When I take the square root, I have to remember to put the plus or minus there. My answers are square root of 6 or negative square root of 6. Those are my two answers. Okay? Let me pull up my calculator here and show you what the square root of 6 is. Here's my square root button. It's right above the x squared. So I have the square root of 6. Let's see what that is. Yeah, 2.4494897. It's an irrational number, non-terminating, non-repeating decimal. Of course, the Desmos just gave me 2.449. They rounded. That's fine. But it's actually the square root of 6 and negative the square root of 6. Okay? It's called the square root method because we take the square root of both sides. Let me see. Yes, the x-intercepts are irrational. Okay? So when you cannot factor, we still try to factor first, but when we can't, there are two methods. We either do the square root method, okay, or we do use the quadratic formula. So the square root method, we saw what that entailed, right? What we do is we add 6, we get the x squared by itself, and then we take the square root of both sides. Same thing here, but what I'm trying to isolate is whatever is squared. Okay, so I'm going to add 15. I get 3 times x minus 4 squared equals 15. I divide by 3. I'm trying to isolate the x minus 4 squared. I get x minus 4 squared equals 5. Once I have something squared equals something else, I take the square root of both sides. Now I have x minus 4 equals plus or minus the square root of 5. Just like I had up here, once I took the square root of x squared, I had x. The square root of x minus 4 squared, x minus 4. Okay? Not quite done because I do want to get the x by itself. So my last step would be to add 4 to the other side. And we write that as 4 plus or minus the square root of 5. Now these are two separate numbers. 4 plus square root of 5, 4 minus square root of 5. Those are the two numbers that I got for x. X either equals 4 plus square root of 5 or x equals 4 minus the square root of 5. If I want to see what that is, let's see, clear this off. Can I quit, please? Okay, sorry, not letting me get out of there. Let's see what that is. 4 plus the square root of 5. So that's about 6.236. Okay, 6.236 about. Let's see what 4 minus the square root of 5 is. That's about 1.764. Let's go with 1.764. Okay, so that's what we get. Those two answers. With the exact answers are 4 plus the square root of 5, 4 minus the square root of 5. Okay, for this equation. If I wanted to see that on Desmos, let's just double check it, right? Y equals 3 times x minus 4 squared minus 15, I guess it was. Let's see. 1.764, 6.236. That's where the zeros are. Is that what we said? 1.76, whatever. Let's see. I have to scroll down. Yep. 1.764, 6.236. Okay. Right. I'm going to stop here and just pick up the quadratic formula with the next video. Okay? All right. Watch the next video. It's going to be short. It's just this last problem. All right. See you then.